everybody, and welcome back to Tech Art for All. I'm really glad to see that you're back to continue learning Mel scripting. And you might have noticed that the song to my intro has changed. And I ran into some copyright infringement issues, and I understand that the owners, rightful owners of the song, probably don't want people using it. But that's okay. I like the new song, and I hope you like it as well. And without further delay, let's get started on today's lesson. Today we're gonna actually write our first script. I hope you guys have been practicing the content of the previous tutorials. We went over creating variables, what the different variable types are. We went over if statements and for loops, and we're gonna try to use all of those to create or write our first Mel script. So let's get started. One of the exercises that I think would be kind of neat to see is basically write a Mel script that loops through all the nodes in the scene. I have kind of like a simple scene with a couple of new nodes I created. So loop through all the nodes that exist in the scene, and then also print what kind of node type they are. So let's get started. So the first thing we want to do is get a list or an array, a string array of all the nodes that are in the scene. I know how to do that, but since I'm assuming that you guys don't, let's start out with going to the documentation, and I'll do my best to pretend that I don't know what the command is, and we'll kind of start searching together. So we're going to go to Mel commands. This is the first time, I'm going to pretend this is the first time I'm using the documentation, and I don't know what command to use to get all the nodes. So I would probably go in here and start typing some keywords. Let's see, nodes. Okay, so there's list nodes with incorrect names, that's not it. Plugin node stripped, not it. Selected nodes, that's interesting. What does this do? This command, oh, it's obsolete. Okay, let's not use it. Maybe node something. Let's look at attribute, all node types, create here, create node, list node types. Let's see what that does. List node types. List dependency node types satisfying a specific classification string. Seek. Okay, that's not it. Node cat. So you, in this case, would probably spend a lot of time trying to go through that documentation, and the reason is because the command that lists node types is, the name is probably not familiar to a lot of people. So let's try using Google together. Mel get all nodes in scene. Okay, so look at that. I typed Mel get all nodes in scene, and the first thing that comes up is ls command. So let's see what the ls command is. Some of you may be familiar with the command from ls command from Unix, which kind of gives you a list of files and directories. The ls command returns the names and optionally the type names of objects in the scene. Okay, so this looks like it's the right command. So in this case, searching in the doc was unfruitful, but when we did a Google search, it came up with the ls command. So let's give that a try. Let's just type ls semicolon, see what happens. Okay, you can see the result is a string array with the names of all the nodes in the scene. And you're probably, you are potentially surprised because it looks like we only have, 10 nodes or something like that, but actually it's outputting quite a lot more. And the reason is because Maya is trying to be actually helpful by only showing you the nodes that you are most likely interested in, but in fact there's a lot more nodes inside a default scene. So if we go to display and turn off DAG objects only, you can see there's all these other nodes, the kind of default nodes that need to exist in a brand new scene. So now that we know how to get a list of nodes, let's try to put them into a variable. So hopefully you remember that if you want to take the output of a command and put it into a variable, you have to use the diagonal quote from that's below the escape key on your keyboard. So you kind of wrap the command with this character, and we're going to put it into a string array. String, because it's returning a string array. All scene nodes, and we're going to put the 2 square brackets to denote that it's an array. So we have a variable called all scene nodes. It's of type string, and it's an array because we got these brackets, and we're going to take the output from the ls command, which will print out or return all the nodes, and we're going to populate it into the array. So run that, okay. And now if we print this variable, it should return the same, should print the same nodes. So this time it's a little bit more clear because it actually, when the array gets printed, it automatically prints every element on a new line, which is kind of nice. So here's my print statement, print statement, and here's all the nodes that it printed, except for that last line. The last line is just like this default callback that gets printed, so don't pay attention to that. So what do we need to do to print or get information and print information for each node? We should create a for loop. So let's do that. We're gonna, since we're iterating through each node in the array, let's just use the kind of like the simplest for loop. It's the for in loop. So I'm going to create a new variable that's going to store each item in the array every time it loops. So I'm going to call it node, or let's call it scene node, and then in all scene nodes. I'm going to actually comment out the print statement just so that it's not confusing us. I'm going to keep it, but I'm going to comment it out with a double /. We're going to open and close bracket. If you get the double bracket, that's just Maya trying to be helpful, but the way I work, it usually kind of adds that extra bracket. I guess usually what people do is they'll type the open bracket, hit enter, and then the new bracket shows up automatically. If you want to work that way, by all means do it. I guess it makes it easier. So this loop, it's gonna loop through all the items or all the elements in all the scene node variable, string array variable, and for each time it loops, it will store the current node inside this regular string variable. And then as a test, we can just say print scene node. And just to review, so the first time it's going to start the first element inside of scene node, it's going to print it. The next time it's going to take the second element in all scene nodes stored inside of scene node and print it. I'm going to clear that, and let's see what happens. Okay, so it actually printed it, but it's all kind of, because there's no spaces between the nodes, it looks like a jarbled mess. So let's add a new line character. We went over that in one of the previous tutorials or lessons. And the new line character is actually 2 characters. It's \n. So \n, whenever Maya sees that, it will think that it's a new line character. So now when we print it, it prints every node. So it looped through the array and printed every node with a new line character. So the next thing we want to do, I'm going to remove that new line character. Actually, let's keep it. Fine, I'll keep it towards the end. So the next thing we want to do is we're going to find out, hey, what, for each node, what is its node type? So in Maya, every node has a node type, because there's so many different node types, and Maya needs to treat them differently. And also it's good for the user to know that, hey, I have a poly mesh or a NURBS shape or a light or a camera. So Maya has this concept of node types. Um, so let's create a new. Actually, let's just output the node type really quick. Once again, I don't know what the command is to get a node type, and we can go to the help, and maybe I'm gonna type and see what comes up. So it says all node types, blind data types, find type. You know, to me those don't make sense. Item filter type, list node types, is type, node type. Okay, that's interesting. Node type. Let's look at node type. Node type. This command returns a string which identifies the given node's type. Aha! Perfect. This is exactly what we need. So we're going to use node type. And as you can see, a lot of the, or most of the commands inside of Mel are also using the camel case, where each new word starts with a capital letter. So it was node type. And then let's see, let's look at an example of how node type is used. Okay, so here they're creating a sphere called balloon. So I personally know that -n means name. So it's called balloon, and then it says node type balloon. Okay, it's as simple as that. So you just run node type and give it the node name. In our case, the node name is stored inside the variable, and Maya understands that if you provide a variable, it's actually, it's going to look what's inside the variable and use that. Node type. Let's see what happens if we run this. Okay, interesting. So it says, did it do anything? Yeah, so I think what's happening is node type is being ran, but we're not storing that information anywhere, and we're certainly not printing it. So actually, you know what? Before we do that, I'm gonna copy that, put it down here, and let's give it a real node, pcube. So I'm gonna select pcube, and when I selected pcube, Maya output a lot of stuff, and it's basically up to us to know how to sift through this information and figure out, when I selected this cube, what's the command that actually selected it. So anything that has a / I would ignore, because it's either an output or a comment. It's basically useless information. And then there's going to be some mel commands that you just have to know that they're kind of callbacks. So for example, Maya has render setup. It's very, very unlikely that that's the thing that selected the node. And then it repeats again for some reason. Then you have a time control command. Also, okay, time control, what does that have to do with selection? That's probably not it. And then over here, we have the select r pcube. So this definitely looks like the command that's used to select the cube. And what I'm going to do is I'm just going to grab the node name from here. I could have done it a different way. I could have selected, the name here or up here, but this is, because I have the script editor open, I usually work this way. Or you can just, transcribe the name down here. So I'm gonna give it the real node name, and it has to be, actually, let's give it without the nodes, without the quotes, and see what happens. It might still work. Aha, so that actually still worked. It's always a good idea to give it inside of quotes. In this case, it happened to work, but you always script with intent, and that will lead to less issues. So once again, I'm gonna say node type pcube1, and then it says result transform. Okay, so we know that indeed pcube1 is a transform, and so we know that the node type command is returning the right thing. So let's go back up top, and we'll, in order to capture the output of node type, we'll use those diagonal quotes that's below the escape key. I'm sorry if I'm reiterating the same information over and over again. I think it's pretty useful to do that when you're learning. And let's put it inside a string variable, node type. So, I could have called it anything I just decided to call it node type. And now we're going to print node type. So here we're, in this line, we're capturing the output, which is the node type, and here we're actually printing it. So let's try it again. And then you can see that we get, let's see. Oh, interesting. Yeah. Let's add a new line so that it's easier to read. Print. So we're going to print the node. We're going to go to the new line. We're going to print the node type. And then after that, we're going to do 2 new lines as to separate the information for each node. Let's print that again. Okay, now we get these pairs, right? And we can see that time1 is a node of type time. Sequence manager 1 is a node type sequence manager. And so on. And as you probably see a pattern for a lot of these nodes, and the pattern is that when Maya creates a node, it usually names it with the node type, but a lot of times they'll put a number after it, you know, in order to make it unique. You can kind of see it for all of these. Let's see if we can find the resolution. So here's one where it's different. It's like default resolution, but the node type is resolution. So how can we make this script a little bit nicer? You know, if we're writing this for a user, they might run it and go like, I don't understand what this information is. So let's add some more kind of like information in the output so that it's a lot more understandable as to what's going on. So we're gonna say print, and I'm going to say node type for node. So it's going to say node type for node, and then it's going to print the node. And then I can say, without giving it a new line, I'm going to say space is space. We're going to print node type and then new line. So this is a kind of a bit of a messy way to do it, but I want to make sure it's a bit simplified for you guys at this point. So hopefully the output is going to be node type for node colon, and then it's going to give you the node, and then it's going to say is, and then it's going to give you the type. So let me clear that and run it. And we have an error. Why do we have an error? Because I forgot to put the semicolon in. You see, everybody makes mistakes. And certainly, you know, if you switch between Python and Mel, you'll see that this kind of mistake is going to happen often, especially if you're like in Python land for a few weeks and you go back to Mel for some reason and you start forgetting the semicolons. So let's run it again. Okay, so we can see now the output is a little bit more clear. It says node type for node time is time. Node type for node sequence manager is sequence manager. So now the information is a little bit more readable to the user. So before I finish this lesson, I want to mention one interesting thing. A lot of people will tell you that, oh, you know, don't use Mel because Mel is really slow. And I think, you know, that's not an inaccurate statement. I think if you use, it depends on how you use Mel. If you use Mel directly and you kind of use Mel for every piece of computation, then it tends to be slow, especially if you're processing a lot of information. For example, if you're trying to set the color for all the vertices in a super high dense poly mesh using Mel, if you're going vert by vert by vert, that's going to take a long time. But one thing a good Mel scripter will know how to do is how to take advantage of a command, so that even though you're evoking the command using Mel, you're evoking C++ command, and if it processes all the information inside one iteration of that C++ command, then Mel could be really, really fast. So it's something that comes with practice, but basically you can batch uh, processes inside of the C++ command. So if you iterate through each vertex in mel and you say like, oh, vertex 1 make it blue, vertex 2 make it blue, vertex 3, and you go through like a million vertices, that's going to be fast. But if you just say, hey, take vertex 1 through 1 million and make it blue in one command, that's super super fast because all of the setting of colors actually happens inside of C++ instead of mel. So just know that yes, Mel could be slow, and sometimes Mel could be really, really fast. Uh, just something to be aware of. Thank you for joining me, and I hope to see you next time.